in the interest of going to simplify things, we are going to highlight 4 common sequences. These are must-know sequences. Only 4. Anything that you have fingers for, I think we're okay. The first one, they're also in the book, but I'm going to duplicate them here. 2, 4, 8. You might have seen these in a previous example, 32. The formula, and these are all explicit formulas, these are powers of 2. The first one, 2 to the power of 1. Second one, 2 to the power of 2, 2 to the power of 3. So 2 to the power of whatever the position is. Is everyone happy that that is the formula for that? That matches that sequence. It keeps going, of course. Next one will be powers of 3. 3, 9, 27, 81. What's the next one? 243. Powers of 3. We should know some powers of 3 anyway. Next one I think we have seen before. 1, 4, 9, 16, 25. Those are the position squared. Position 1 squared, 1. Position 2 squared, 2. 4. Position 3 squared, 9. There you go. The square numbers. And one more, when I cube the position. 64, 125. That is the position to the power of 3. Those are ones I want to know. Nothing more right now. So you need to know the first 5 or so, or at least the formula, or both would be ideal, I think. Yeah, both. We need to know both. Any questions on any one of those 4? Powers of 2, powers of 3, position squared, position cubed. I don't think that's too hard to remember. All right. Now, to make it a little more spicy, we want to use these to identify other sequences that are built on these. Exercise 1.5. I'll give you something, and that will be quiz number 1, question 1b. I'll give you a sequence that is fairly closely based on one of those. Which one is it, and how is it modified? How can I modify that formula to find the formula for the given sequence? Here's the first one. You have these in front of you, so I'll move up a little bit. 3, 5, 9, 17, 33. Yeah, I can see them all. So, there's a process here. First of all, we have to figure out which one of the 4 is this built on. Which is the closest to this given sequence. So you only have 4. You kind of go through them one at a time, or some look to it maybe reminds you of one of the 4. The more you practice this, the better it gets, and there will be a bunch of problems where you can practice that. We only have 4 examples. Problem 1.5 has 11 more. So by the time you finish them, If you don't look at the answers, you're going to be just fine. I claim that this is the closest to the first one of the four, powers of 2. But it's not the same. What is the adjustment to go from the powers of 2 to this sequence? Well, depending on which one you look at first. Let's build from the powers of 2 to get the sequence. I add 1 every time. So this is 2 to the n here. This is the one I have to remember. And you see I just add 1 every time. That means the given sequence has formula 2 to the n, everything plus 1. Because that's exactly what I did. I took the 2 to the n sequence and I added 1. How do we feel about that? A little bit of practice. Right now it's the first example. So you're not going to be a pro after these 4 examples. Don't expect it. You need to do the other 11. So low expectations for the early examples. Next one, 2. No, not next one. There's a question.
Because I said -1. Should you not do like an equal 2 in like your position?
If I say -1 instead, I'm building it on the top one. So I would then, my new sequence would then be, look at the top 2 minus 1 is 1. 4 minus 1 is 3. And that's not the sequence I have. In order to get the sequence that's given in the question, I have to increase the memorized one. I have to go up because it's a 3 instead of a 2. It's a 5 instead of a 4. So if I'm building from the powers of 2 to get the given sequence, I have to go up.
Okay. So you would minus it.
But it's important to first, it's totally fine to recognize there's a plus minus 1 and then figuring out, okay, from the memorized one to the target, which one is it?
You could just make your own one. Because I just think like 3 times.
It's always going to be one of these 4
Okay.
to make it easier for you. But if you happen to see something else, doubtful, but yeah. It's specifically going to be one of these 4.
Okay.
Yeah, just to make it easier so it's not too overwhelming. So in this case, another sequence could have been a -1. But this one, I have to go up, so it has to be plus. Let's try the next one. This is one kind of question where volume helps. The more I do, the better it gets. 2, 8, 18, 32, 50. And in the beginning, it's going to feel like, what? This does not look like any of them. I have to zoom out a little bit. But if I just look a little bit, give it time, you only have 4 options. Right? To make it manageable, it's going to be one of those 4. So you can go one at a time. Does it sort of behave like powers of 2? Well, the 2 and the 2 are the same, but the 4 and the 8 and the 18, it starts to deviate, so that doesn't feel right. It's not going to be exactly the same and then different, so it's not the first one. Does it look like powers of 3? I could argue that yes. The 3 and the 2, the 9 and the 8, is a difference of 1, but then that doesn't stay consistent. It becomes something else. So probably not. Next one, the square numbers. Is it close to that with some consistent adjustment? there has to be some consistent change between the two. Square numbers, what could that be? Does it work? Do you see anything? What do you see? Times 2. So if I look at my square numbers, to just sort of have them close together, to see it maybe a little bit better, this is just going to be times 2 to get from my memorized sequence, I'll call it, to the given one. And that's consistent throughout. So the formula for this new sequence is going to be 2 times n squared. Or n squared times 2, it doesn't matter how you write it. So I could add or subtract the number and adjust the memorized one to make a new one. I could multiply, and we're not going to multiply with something big. It's going to be a 2 and a 3, something nice, easy to recognize. I can also multiply every term to get the corresponding terms in the new sequence, and it's built on the memorized one. Everyone happy with the second one? We have to be happy with 1 and 2 before 3 and 4 come along. Now I know you probably need more practice before you're going to be super comfortable with 3 and 4, but I need to show it to you. So 1, 2, 4, 8, 16. Zoom out to see my sequences, which ultimately you can memorize, or what many people do, as soon as they get the quiz, they write them down on the cover. Either way, you need to know them somehow, so that you can match the given sequence with one of the 4. So the first issue isn't what the formula is. The first issue is which one is this built on? Which one of the 4? That is the first issue. You don't have to know everything right away. Just find which one of the 4 it is, and then how is it adjusted? Which one of the 4 is it built on? She says powers of 2. There is agreement. All right. So now, let's write the powers of, whoops, what was this? Oh, okay. Let's write the powers of 2, sort of under it, to see it's not quite the same, certainly close. And then we can zoom in a little and see how is one adjusted to get the next one. Just in words. How is the bottom one, which is the one I memorized, how is it adjusted? Just in words. What is done to it to get the top one? Okay. Divide by 2, half. Perfect. Divide by 2, divide by 2, divide by 2. I'm going to erase those in a second. So this would be the formula, however you want to write it, 2 to the n over 2. Or I don't like an actual division. Making it a fraction is a little nicer. Is everyone happy with that? So we could add, subtract, multiply, divide. It's all good. It's all good. But I want to elaborate on this a little bit. Notice that this can be written as 2 to the n times 2 to the negative 1. And then when I put these guys together, I add the exponents to get that. So that's another formula for the same thing. And that tells me something. That tells me more than you might think right now. If I want to make this original sequence, 1, 2, 3, 4, 5, I have to, it's an explicit formula, so I just need the position. Okay. If I want to, I'm standing over there. I'm ready to use the formula, the circle one, and find the term in that position. Well, n is 1. That's the position I'm in. So I plug in n equal to 1, and I get 2 to the power of 0. I have to erase myself here. 2 to the power of 0, which is 1. The 1 I get, of course. If I now stand over here, now n is equal to 2. The position is 2. I plug it into the formula. I calculate the power of 2, 2 to the power of 2 minus 1. Which is exactly the same as this one. Because this is also 2 to the 1. And I get, oh, now I have to erase myself. Whoops. Where's my erase button? Bye-bye me. 2 to the 1, which is 2. Now I go on to the third position. I calculate, this is the formula for the sequence, 2 to the 3 minus 1, which is 2 to the 2, which is this one, which is 4. Now I go on to position 4, plugging in a 4 there, getting 2 to the 4 minus 1, 2 to the power of 3, which is this one. And so on and so on. So what this tells me is the new sequence is the base memorized one shifted to the right, one space. Because if I'm at any position in my new sequence, position 3, for example, how is that related to the original, this one, the original one? Well, I'm going to subtract 1 from the position, which means in the original, I'm 1 position back. So if I'm over here trying to calculate this one, I'm going to subtract 1 from the position, which means 2 to the power of 1 position less. So it's a shift that is happening. If I compare the 2 to the n original formula to 2 to the n minus 1, I can see here n is replaced with n minus 1. And that's always going to indicate a shift in the original sequence. Let's do one more and see. Let's do one more. Ooh, it could be enough space. Let's do 0, 1, 8, 27, 64, and so on. Which is that closest to? Which of these top sequences? The cube numbers. So my cube numbers were 1, 8, 27, 64, 125, and so on. What is the link between the two? To go from my memorized one to the new one, it's a shift.
One position less.
It's shifted.
Yeah.
So there's another way of making a new sequence, by shifting the original. Shifting the original. So now I have to figure out how is this formula adjusted to give me my new one. I claim it is this. To get, let's make the sequence. Let's make this sequence. To check the formula. I'm not going to bother with the first one right now. If I want to be in position 3, I want to find this one. This formula, my attempt, says take 1 off the position and cube that instead. Well, that's exactly this one. So when I replace the base, the original n, with an n minus 1, it's a shift of that original sequence to the right by 1 position. And I mean, you can sort of think of it as a guessing game right now. That if I try a formula, I can use that formula to make a sequence, and if I get the given sequence, then that means the formula is correct. You don't have to just know what these formulas look like and stop. If I'm guessing, if I feel this is a little bit of a guess, I'm not quite sure, make the sequence. Do you get this? If yes, then you're right. So if I see a shift happening from the base memorized one to get the new one, if it's a shifting, then the formula can be obtained by replacing the n, take it out, it's gone, and putting in an n minus 1. Plus or minus. If I shift to the right, it's a minus. If I shift to the left, it's a plus. But I can try a formula. Remember that there's some replacing happening. I'm not sure which one it is. Test it. If I get the sequence, it's fine. Yeah.
Why is it not 3n in this one?
Where are you now?
Like the previous one was 2n minus
The
1?
2. It's powers of 2. Everything was 2's.
Oh, right. The power of 2.
Yeah, it's not the cube. Yeah. So in the case of the powers, there was the option to divide or see it as a shift. In these ones, maybe not so much. Not so much. So I understand that you don't feel great about this. So we can take the rest of the time to do whatever you need to do. Work on the problems, run away screaming, anything in between. Important problems. 1.2 on page 15, which when people watch the video may or may not be page 15. Problem 1.1, it's very good to do first. And problem 1.4 and problem 1.5.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.